This video is meant for Mrs. Rose's AP Calculus class, and the topic is summation notation. Alright, so summation notation is a standard notation for writing sums in a compact form. So if you're trying to write out am plus 1 plus blah 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 all the way out to an, the more compact way to write that is this, where the sigma is a capital Greek letter. It stands for sum, and the notation j equals m on the bottom means start at the number m and end at the number n. So for example, if you start from 1 and go to 5 of j squared, we have 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. And j can really be any variable. I've seen it very frequently as k or as I, obviously as j, but it really can be anything. Okay, so usually whatever the summation is, it's going to be a recognizable pattern. And this one starts with the number 2 and ends with the number 5. So we have k equals 2 to 5, and I have k squared plus k. Again, the k, the actual variable doesn't matter, it could be j. So for the next summation, we have the square roots, and they start at 1, go to 2, and they keep going all the way to n. So we're going to start with j equals 1 to n, and then we have the square root of j plus j cubed. Very straightforward. Then we have our linearity and power sum formulas. By the end of the month, you should have these memorized. These are probably more important and probably harder to remember. But we use them when we're trying to find the summations, such as the following examples. When you have something very straightforward with just a few numbers, it's pretty easy to write them all out, plug them all into your calculator, and get a number answer. But it gets slightly more complicated when you have something like 7k squared minus 4k plus 9. So when we have something like this, what we can do is separate them into different pieces, where we can have k equals 0 and 100, and then we have k squared here. So at this point, we can use our power sum formulas, and the power sum for k squared is going to be n times n plus 1 times 2 times n plus 1 all over 6. And even though the power sum formula starts at 1 normally, 0 doesn't really matter when you have the variable part, because you're just going to be adding 7 times 0 squared. So we can plug this into our calculator and get a number answer. When you calculate that out, you should get 2,368,450. Okay, then we're going to look at the negative 4k. So I'm going to write that as 4 times k equals 0 to 100 of k. So this is going to be 4 times, and the power sum formula for just k is going to be 100 times 100 plus 1 all over 2. And when you plug that into your calculator, you're going to get 20,200. And finally, we're going to look at 9 from 0 to 100 times 1. Now this one, even though it looks the simplest, is really the hardest, because on your formula sheet, the number that you start with is 0. No, the number you start with is 1 normally. So this is basically equivalent to 9 times sigma from k equals 1 to 101 of 1. So that is your last linearity power sum, and that's going to be 9 times 101, which is 909. So your final summation can be written like this. So we have the 7k squared part minus the 4k part plus 9, And when you add all of that up together, that equals 2,349,159. Okay. All right, if you need any help on your homework and these videos don't do enough for you, please come see me during Calc morning and I'd be happy to help you.